Sairam to all of you. Welcome back to the continuity of studies about atoms, molecules, and their various mathematical aspects that we have to study with respect to this. Now, if you remember the earlier parts, we started with an introductory sort of a thing, then slowly moved on to understand some basic laws and theories, and then we realized that measurements are part of all these studies. And therefore, first we studied about the various SI units that are there for these parts. So now the actual calculation part starts here. And that concept in this particular aspect is called as mole concept. It's something new, you have not come across this word till date. So this is a new concept for you, but this forms the very basis of our entire study for this 2 years. You understand this one concept, it forms a basis in every segment that you are going to study. It involves a lot of mathematics also, so kindly be aware, kindly revise your minimum mathematical studies that you have done in your earlier classes. So let's go into this, what is all about this mole concept, and before we get into some concepts and other things, let's get into our personal lives. So this probably, if you go to a market, you are generally buying many things, and fruits is definitely one of the important components that we tend to buy. For a healthy body, good amount of fruits gives us a lot of vitamins and other requirements for our body usage. Now what I've done is I've put up a real life situation where if I've purchased 5 different fruits here, banana, sapota, apple, mango and pomegranate. Now it so happened that whenever you go to market, you can either purchase this in terms of kgs, you can purchase it like 1 kg, 2 kg or so, or there is another aspect which is dealt, which is in terms of dozen. Now the moment you purchase something in dozen, the count is same in every case, irrespective of which fruit it is. Whether it is banana or sapota, which is chiku, we call it apple, mango, pomegranate. In Kannada, we call it as dalimbe hannu. So all this, if you take it in terms of kg, that's fine. But if you purchase it in terms of dozen, the count that you get is always 12. Now the question is, who decided this 12? Why should 1 dozen be 12? Now that is a general basis that we take for day-to-day selling of products. You can't argue why it is taken as 12 as such. It is just that with that basis, the general marketing happens. So one thing you have to understand here is that any fruit that you take, 1 dozen indicates 12 in number. Now I have given their weights, which is approximate. This is an important word now because various sizes, if you take, naturally the overall weight will also change. So this banana, actually not the bigger ones, smaller ones, which you call it as mitka banana. So generally it weighs around say 600 grams, generally. Now that is why I stress upon this word approximate. Now if you go to a market and then weight exactly, you may not get it the same. Sapota is, if you take this 12 in number, naturally the weight will be a little more because the size of sapotas are also generally larger. Now as I told you, we believe in approximation of certain similar sizes. The next set of fruits are apple and mango, and both, when I take it 12 in number, generally the weight of mango will be little more. Reason for that, because if you remember, just visualize mango. So it has an outer covering and then it has an inside hard mass which is present. Along with that, there is a lot of fluid that is flowing around, but that hard mass gives it a lot of weight. So therefore, apple will generally be lesser in weight when you compare the same quantities with respect to mango. And very naturally, pomegranate is pretty large because, a lot of fruit material which is present. So all this, you have to visualize within yourselves as such. So what is the main point that I want to highlight here is that, as an example, when I have taken 5 different fruits, when I purchase it in terms of dozen, the quantity remains same, which is equal to 12. What definitely differs is the mass or weight of those compounds. Depending on their various sizes, naturally their masses are differing. Now there's no chemistry that I've spoken here, it is just the general studies that we undertake in our day-to-day life. But understanding this entire concept is very important. Hoping that you have understood this well, now let me move on into some chemistry of this. So considering those same 5 fruits, once again considering that if I purchase in terms of 1 dozen, there are 12 in number. In chemical studies, the very heading that we saw, mole is nothing but equivalent to dozen. Now how was this number determined? It was a general marketable basis, but the moment we speak of sciences, naturally experimentation, various theories, laws come into picture. So it was seen that like the way we have different fruits, still 1 dozen indicates 12. It was seen that different elements, hydrogen, oxygen, water, sodium and hydrochloric acid, all these names you must have come across till date. So all this, when they tried to work upon to find out how many atoms are there, they realized that this was the number which was repeating in every space. Now just see the magnitude of this number, 6.022 into 10 raised to 23, which indicates that after 1 you have around 23 zeros, such a large number. So which means that if you go back to the definition of atom, paramanu, which was the smallest indivisible particle. Now that is what is the smallest indivisible particle, that when you consider a standard like you had dozen, same way if you consider something called as mole, that is equivalent to this number in all the cases. You are able to see that the same number is repeating everywhere. But what is differing is, depending on the compounds that you have taken, the mass of those compounds are differing. Come back here, banana mass, if you can just check out sapota and then check out apple. Dozen quantity wise it is same, but mass is differing. Exactly the same thing is happening here. Now where did I get this 2? No doubt this was approximation, because that depended on the size, but here I have not written anything like that. I have not written approximate and all. I have just written it as atomic mass, because these chemical entities have undergone experimentations, have undergone various theories, and this is what has been proposed in the final state. So therefore hydrogen mass is given as 2. Now as conveyed in the earlier classes, 1 to 20 elements, you will have to know atomic number and mass number of those compounds. What are the masses? Now hydrogen, atomic number is 1, mass is also 1, but then since I have taken H2, I have already conveyed that why we take H2 is because hydrogen is a gas. If you take it singly, it will not be stable. Therefore, it has to be combined with somebody else. So because it is H2, the mass is 2. Now what does this mean is, in 2 gram of hydrogen, you will find 6.022 into 10 raised to 23. This is a big number. So many atoms or molecules are present in this case. Now should I call this as atom or a molecule? When I take it as H, then I will call it as atom, because that is the indivisible particle. And what is molecule? It is the stablest form. And what is the stablest form of hydrogen? It is H2. Therefore, this I can consider that in 2 gram I can have 6.022 into 10 raised to 23 molecules. Come to the second one now, oxygen. Oxygen atomic number is 8, mass number is 16, and because there are 2, so in these parts when we consider here, the overall content part in this case will be 2. Now here, though it has been shown as 16 as such, because when you consider oxygen, you have 2 things here, O2 as oxygen, O3 as ozone. So please be aware that oxygen mass is 16 gram with atomic number 8. If you take it as O2, it will become equivalent to 32 gram. If you take it as O3, 16 into 3 will become 48 gram. So this is why this factor has to be understood clearly, where 16 gram indicates one single atom of oxygen, whereas 32 gram indicates one molecule of oxygen. 48 grams indicates ozone, which is O3. So similarly, moving further, we have regarding water the calculation, to atoms of hydrogen are there, into 1, mass of hydrogen is 1, we know it very well. Oxygen, there is only one atom and the mass is 16. Oxygen mass is 16. So if you calculate this part, 2 plus 16 will be equal to 18. That is what is given there. What is important to be understood is that 18 grams of water will contain so many number of molecules. Sodium, the atomic number is 23. Sodium, because it is a solid, it is not written like H2 or O2. Therefore, sodium is written only as Na, and Na, because it is atomic form, this can be considered as 23 grams of sodium has 6.022 into 10 raised to 23 atoms. Last part, hydrochloric acid, hydrogen is 1. If you go through the periodic table, you will realize that chlorine mass is 35.5. So when you add them together, it becomes equivalent to 36.5. So this is how we can understand now with respect to a study correlation with these fruits. We understand that for 1 dozen, the quantity has remained same, but mass has varied. Exactly the same. What is 1 mole is the molecular mass of a stable component which is present. So in this 1 mole which is present here, I have considered the molecule of hydrogen. So when I consider molecule, then I should write this as 6.022 into 10 raised to 23. Small molecules are combining together. In case of hydrogen, in case of oxygen, when I consider 16 gram, then this becomes 6.022 into 10 raised to 23 atoms. But if I consider it as 32 gram, because why should I consider 32? Because when I consider it as O2, then naturally it will be into 2. So when it is O2 32 grams, that time this same factor you can write it as 6.022 into 10 raised to 23. The word that we use here is molecules. So this is how the variation in these cases are done. Similarly, you can understand that in 18 gram of water, this is the amount of substance that is present. So if you remember in the SI units, we had something called as amount of substance, which was given in terms of mole. This is nothing but the mole. So this is what we have about the mole concept, where one thing has to be absolutely clear, that 1 mole is equal to 6.022 into 10 raised to 23. What are those? They can be atoms or molecules, or in simplest form you can just say that particles. So 1 mole is nothing but this is the equivalent number, and it is also equal to the molar mass of the compounds which have been present. So this is how we analyze the mole concept which is there. So just certain points for you to understand and maybe define them. A mole is the amount of substance. This is the SI unit part that we have studied, that contains as many elementary entities. It can be anything. It can be in terms of atoms, can be in terms of molecules, or any other particles. Now for now you need not worry about the any other particles. We will study those aspects later. So basically atoms and molecules it can be, as there are atoms in exactly 0.012 kg or 12 gram of carbon isotope. Now why this carbon came into picture all of a sudden? So when they started to study about the mass of these compounds, first they studied about hydrogen. Now the problem with hydrogen was, we know very well that hydrogen has 1 proton inside, it has 1 electron outside, but it does not have any neutron in it. So since it did not have any neutron, it became difficult to be taken as a standard. And therefore, after hydrogen did not work out clearly, they have taken carbon as a standard. So it is not that they could have even taken oxygen, they could have taken nitrogen, but for studies, carbon was taken as standard. So what does the statement mean is, a mole is the amount of a substance that will have so many atoms or molecules in exactly 12 gram of carbon, which indicates that I can write it 1 mole is equal to 12 gram of carbon, which is also equivalent to 6.022 into 10 raised to 23 atoms or molecules or any particles. So the term mole has been derived from Latin word heap or a pile. These are basic general understandings about this, found out by Ostwald, the scientist who was there. Now it so happened that generally they propose the theory, but what happens is nowadays the technology is very good. But earlier days it was not so. Once you propose a theory, it would take a lot of time to formulate it to the real world. So that is why probably whenever they proposed, it took a lot of time, and further scientists studied well and brought out this concept. So 1 mole always contains same number of entities no matter what the substance is. What does this mean is that, so when I say 1 mole, so 1 mole is equal to, so this is always equal to 6.022 into 10 raised to 23. Whether it is carbon, sodium, oxygen, nitrogen, anything. What will vary is definitely the mass of that compound. So for example, when I take carbon, it will be equal to 12 gram of carbon. Suppose if I take sodium, this will be equal to, it cannot be again once again 12 because this was of carbon. So when I consider sodium, it will be equal to 23 gram of sodium. So this is one important aspect that we need to consider in the study of the atomic forms of various elements. Moving further now in our studies about the mole concept, Avogadro number. Now this number which was there, 6.022 into 10 raised to 23, this was idea was given by the scientist Avogadro, but the problem was he could not directly find out this number. This was found out later, but still because he had given the elementary work for that, this number was later on called as Avogadro number. So what is that? How did they get about? They found out that there are exactly this number of molecules in 12 gram of carbon. This is the first thing that they found out. So that is why the carbon is kept as the basic element for study. And then with respect to that, various other compounds were studied. So now this Avogadro's constant is given by 6.022 into 10 raised to 23 per mole. Per mole means what? For 1 mole, it is 6.022 into 10 raised to 23. So please remember that whenever we consider Avogadro constant, we use this unit per mole. But when we calculate the number of particles, that doesn't have any SI unit. Please understand this aspect very clearly because this is only for per molar calculations only. So the symbol is given as Na. Find out that A is nothing but the subscript of that particular compound. So this was about the Avogadro's number which is present, and this Avogadro number is applicable for all this type of compounds. So where we saw that 1 mole is equal to 6.022 into 10 raised to 23, that is also equal to the molar mass of the compound. What is molar mass? Mass of 1 mole of substance. So that is more like a triangular series of sorts, where 1 mole is equal to 6.022 into 10 raised to 23 is also equal to the molar mass, which is again equivalent to 1 mole. So a triangular sort of thing which is there, where mole of any substance would contain 6.022 into 10 raised to 23 particles. Now what are these particles? If you are considering it as an atom, then all these are atomic forms. Sodium, potassium, copper, all these are in atomic states. So all these elements will contain 6.022 into 10 raised to 23 atoms in their state. So don't get confused with this atoms and the atom that is written here. An atom is basically the indivisible part, and for that 1 mole compound, so many components are present. Now when you consider the second set of compounds here, oxygen, nitrogen, hydrogen, which are all gases, their stable state is in O2, N2 and H2. So therefore the count is written as 6.022 into 10 raised to 23, exactly the same number, but what are they? They are in molecules. Whereas here it was in atoms, now it is in molecules. The next set of compounds, molecular compounds, once again they are molecules. It is just that, if you remember, these were hetero-homo. If you go back to that concept, these are homo, which means same. These are different, NH3, water, methane, CH4 is methane. So this is homonuclear, this is heteronuclear, but both of them come under the study of molecules. Next set is about ions. What are ions? This is something that you have studied in the earlier class. Charged particles are called as ions. So Na plus, Cu2 plus, Ag plus, all these are charged particles. So what will these charged particles have? So suppose if I consider 1 mole of Na plus, what does 1 mole of Na plus have? See, 1 mole of Na had 6.022 into 10 raised to 23 atoms, whereas 1 mole of Na plus will have 6.022 into 10 raised to 23 ions, because it is in ionic form. So the form it is, that is the form we utilize. Ionic compounds like NaCl, NaNO3 and K2SO4 are called as formula unit. Now why do we call this as formula unit is because these are all stable ionic compounds. NaCl, sodium chloride, sodium nitrate, potassium sulfate. Because they are stabilized, we call them as formula units and they have this particular formula. So this is the differentiation that you find between atoms, molecules, ions and formula units. So similarly here, so these formula units are nothing but stable compounds which are being generated by individual elements as such. So this is how they come across this chemical formula also. Water, H2O, it is nothing but a combination of 2 hydrogen and 1 oxygen, ammonia, sodium chloride. And if you see this example now, sodium nitrate, it contains, so since these are all ionic forms, it contains 1 sodium ion and then this NO3 minus ion which is present. What about this K2SO4? So K2SO4 is actually obtained when you do this cross multiplication. So K2SO4, because the charge on potassium is +1, charge on SO4 is -2. So therefore we find that it has in total 2 potassium ions of +1 charge and 1 SO4 minus ions. In the same way, 3 barium ions and 2 phosphate ions. So this is how various compounds combine together to form large number of atoms and molecules. A small example here, some examples so that we understand the correlation. Many things are already repeated. 1 mole carbon, 1 mole of carbon, now because it is in atomic form, it will be equivalent to 6.022 into 10 raised to 23. 1 mole of oxygen, now remember this is molecular form. See, if I have written as O, then it was atomic form. Since I have written it as O2, it will be molecular form. That is why the number is same, but then it is oxygen molecules. Water, once again the same number. Sodium chloride, once again the same number, 6.022 into 10 raised to 23. It is just that here we used atoms, molecules. Now we are using this terminology of formula units because it is a stable compound which has been formed from ionic parts. Moving further, 1 mole of Ba2 plus ions. Because we talk about ions, the number of ions is same, which is equivalent to Avogadro number. It is nothing but equal to Ba2 plus ions, 6.022 into 10 raised to 23. Now a comparative study, we have it here. This is something that we have to understand now well, where 1 mole of O2, we already know it, we had already seen here. So 1 mole of O2 was nothing but 1 into 6.022 into 10 raised to 23. That is what is 1 mole. What about 0.5 mole? Now for 1 mole, it was 6.022 into 10 raised to 23. For 0.5 mole, a simple calculation where, generally whenever you don't know something, you take it as X. Is it not so? So for 1 mole, this is a known thing now. No need to change anything. For 0.5, how much they are asking? So X is equal to, it is nothing but a cross multiplication. 0.5 into 6.022 into 10 raised to 23. What will be this equal to? 6.022 into 0.5. This, if you undertake calculation, it will be 3.011 into 10 raised to 23 molecules, because the oxygen that has been used there is O2. A direct calculation is shown here. What I have done here is just to give you an idea of how we can calculate things. 1 mole is so much. What about 0.5 mole? In the same way, we shall see another example which is shown here. They are now asking for 0.1 mole. Once again, go back to your basic. We know very well that 1 mole is equal to 6.022 into 10 raised to 23. Here it is molecules. What about 0.1 mole? I don't know this, therefore X. And the moment X comes, what to do? Crossing these parts. So 1 into X, I can always write it as X is equal to 6.022 into 10 raised to 23 into 0.1. This 0.1 has been multiplied with this part. So what will be this equal to then? If you just see the variations that we have in this cases, so 0.1 into 6.022 in these parts will be equal to 0.0622 into 10 raised to 23. This is the calculation that we get. But generally standard form is writing in terms of one digit and then a decimal form. So what I'll do is this 10 raised to 23, let me make it as 10 raised to 22. What I have done there, one 10 I have removed out and that 10 I have multiplied with this, which is equal to 6.022 into 10 raised to 22. This number is important. This is how various calculations are done. So power calculations, I'm sure you are very comfortable with that, where a removal of 110 you can actually multiply to this part. So these are certain examples that we come across with respect to moles form in these cases. A small assignment for you just to see to it that you have understood this concept well. A new concept, don't be panicked with that. A little practice and you can get this very easily. Sample of nitrogen gas consists of 4.22 into 10 raised to 23 molecules of nitrogen. How many moles of nitrogen gas are there? Just be clear with that. 1 mole is equal to 6.022 into 10 raised to 23. This is a known fact for us. Now what they have done, they are told that so many moles are present, 4.22 into 10 raised to 23, and they are asking you to find moles. Earlier the x was on other side, now it is on other side. So it is just a variation that is been seen. So please try to calculate this part. In a metallic piece of magnesium, 8.46 into 10 raised to 24 atoms are present. Calculate the amount of magnesium in moles. Once again a same question, it is just that here it was in terms of molecules, now it has been brought down to atoms. So 1 mole is equal to 6.022 into 10 raised to 23. How many moles is this part? Calculate the number of Cl2 molecules and Cl atoms in 0.25 mole of Cl2 gas. For this, let me just give you a little basic aspect of this. Be clear in these parts that 1 mole of Cl2 will contain 6.022 into 10 raised to 23 molecules. Then they are asking for 0.25. How will you calculate for 0.25 is what they are asking. Now this part was fine. Number of Cl2 molecules was fine. What about the Cl atoms then? We know very well that 1 molecule of Cl2, how many atoms does it has? It has 2 Cl and Cl. So which means that the same 1 mole of Cl2 which has been shown here, where 1 mole of Cl2 is nothing but 2 moles of Cl atoms. This was a molecule, this was a gas. So you just need to multiply into 2 if you want to find the atomic forms. More deeper study into this will be taken up in the next part of our studies that we have. So this is all that we have for mole concept in this chemical arithmetics. Sai Ram.